Hey, Aaron,
Hey, Tim.
why does everyone think we're day drinking on the show today?
This is how rumors get started. No, we're going to go through a really cool drink dispensing solution today.
Yeah, that's right. We're bringing on our colleagues Anton and Gavin to discuss their connected drink dispenser that uses FreeRTOS, API Gateway, Lambda, DynamoDB, KiCad EDA, Autodesk Fusion 360, and somehow even more.
It's quite a mouthful, so stay tuned to this episode of IoT All the Things.
Special Projects Edition.
Hi from Brooklyn, everyone. I'm Erin McGill. I'm a solutions builder here at AWS. So I've lived my tech career on the infrastructure side of the house, first as a sysadmin, then automating infrastructure. So that's kind of where I've developed my skill set. But recently, I've been really interested in IoT projects at home, things that I can do there where I can actually just take a piece of hardware, maybe some wires and a breadboard and a little bit of code and actually make things happen. What about you, Tim? Tell us a little bit
I'm
about
Tim
yourself.
Madison. Yeah, I'm Tim Madison from Pleasantville, New York, and I'm a principal partner SA for IoT. So I spend my days working on really cool IoT projects with partners building things on AWS. I started out as a developer. I was always interested in interacting with the real world, and I've done a bunch of those kinds of projects throughout my career. So I've gone from software development now to solutions architect and having a lot of fun doing it. So it's great to have everybody back today. We're going to be talking all about projects from edge to cloud, idea to fruition. And we're going to bring on our guests, AWS SAs, Anton Shmagin and Gavin Adams.
Right, so they developed a workshop that uses AWS IoT services, API Gateway, Lambda, DynamoDB, and other services to connect IoT connected drink dispensers into the cloud. But before we get started, we wanted to talk some things that we thought that our viewers may find interesting. We talk about hot topics here. Recently, actually, I think earlier this week, AWS Solutions just launched like 9 new versions or updates to their implementations. So these are vetted technical reference implementations designed to help customers solve common problems that we see that customers are having out in the world and help them build faster. So this week, they have released about 9 new solutions. So actually, they have released new solutions such as streaming data for Amazon Kinesis, Cognito user profiles, export reference architecture, but they also did updates to things like the serverless image handler. But one that I wanted to talk about and focus on is, since it has a focus on machine learning, and that's something that we want to focus on here, is called Discovering Hot Topics using machine learning. And I think we have a screenshot of the architecture here. So it's really interesting. What it does is you can just launch it in your account and it automatically, well, the default data source is Twitter, but it takes all of the information from Twitter from a specific topic that you as a customer who deploys this identifies. And it then takes that information, puts it against some of our machine learning services, and then get some insight from it. I was talking to you, Tim, about this, and I thought that was pretty cool. And
Yeah,
they actually take. Yep, go on.
Yeah, sorry. So you shared this with me, and I was really interested in it because last week when we were talking, I think it was last week, we were talking about the bird spy at some point and how I started getting,
Yeah.
last week we did the butterflies, and we talked about how you could train things with recognition and get experience using ML, and it always feels like a really tall mountain to climb to get there. But this,
So much.
like end to end, being able to just take an input source like Twitter and have it pull out things that you're interested in, gives you at least a baseline to get started, and then you can learn more and develop more on top of it. So I'm really excited to try this out. I haven't had a chance to try it out yet since I just learned about it the other day, but I'm definitely going to kick the tires on this and see what it can do.
Yeah, I think it's really cool that since it connects to Twitter, there's so much data there that it will help you get insights into what people are saying around whatever topic you decide. But I just thought it would be really cool. We have a link to the solution that has been published on our solutions page. So I think we'll put the link in the chat stream. I just wanted to talk about that quickly because we have a lot to talk about today. We have our two guests with us, Anton Shmagin and Gavin Adams. Welcome. Thank you so much for joining us today. So, Anton, why don't you tell us a little bit about yourself?
Partner solution architect. I'm working primarily with semiconductor companies like Espressive, ST Microelectronics, NXP, ARM. So deeply rooted in the hardware, although I started AWS as a security architect, so it's kind of funny.
Cool. All right, Gavin,
awesome.
how about you? What have you been doing at AWS?
Yeah, thanks, Aaron and Tim. So Gavin Adams, I'm an IoT specialist solutions architect, meaning I work directly with customers with IoT-centric workloads. So this is near and dear to my heart. I'm representing from Denver, Colorado, so the other side of the Mississippi. So we got some West Coasters here. And my background pretty much has always been tech-related. Started with the internet back in the 90s when it pretty much became popular. And I pretty much have never looked back, but I've always had a penchant to work with physical devices. So yeah, I've just always gravitated toward IoT.
Cool.
Yeah, it is so cool. So thank you so much for joining us today. Can you tell us just a little bit, what is this project that you're going to show us and talk through with us today?
Yeah, so this is the project that we run 3 successful workshops at 3 reInvents, actually much more workshops, but at 3 reInvents. And actually this is how it looks like, right? So it's basically, let me see if I can focus on it.
There we go.
That's it. That's what everyone wants to see. Show us the hardware.
Great.
Cool.
Yes, please.
So it's basically, it has a ESP32 microcontroller from Espressive, some motor control circuitry, the pump, aquarium pump that pressurizes the bottle, the air in the bottle, and that's pretty much it. It's a siphon principle. The moment you're pressurizing the air, the liquid starts flowing to your glass, and in this case, the liquid is just a pure Evian water.
Cool. So, I mean, I think that this is a really cool workshop where you connect both, hardware on site, but also in the cloud. Speaking of the cloud, Gavin, the cloud side is pretty cool. Can you show us what the backend looks like?
Sure. So I'll go ahead and show you an architecture here. A picture's worth 1,000 words. So just starting with, the left-hand side, as we've got our physical actor. So the drink dispenser that Anton just showed on top, and then users that will actually interact through a web browser, through the backend infrastructure, and actually control the device. So I'll start to build this out here, starting with the drink dispenser. So the first thing is that the dispensers are IoT devices, and they communicate with AWS IoT Core via the device gateway. And we use client certificates and private keys to identify and authorize the devices that connect. So in the workshop, you have 100 different drink dispensers, all connected to IoT Core.
Cool. And
from there,
sure, go on.
Oh yeah, I guess. And from there, they're using the MQTT protocol, so they're publishing and subscribing to different topics on the back end that we then interact with.
Very cool. And that communication, because you're using certificates, is it encrypted, or do I have the option to have it encrypted?
Yeah, so with IoT Core, we mandate encryption. So every connection from a device using MQTT, we require TLS 1.2 encryption so that we can ensure that data in transit from the device to IoT Core is fully encrypted. And by using those X509 client certificates, we also do the mutual authentication so that devices can identify the cloud and the cloud can identify the devices too.
Awesome.
So anyways, just to follow on to that, is that every dispenser has its own set of topics that it communicates with. And by that identity is that we can ensure that one dispenser can't see or interact with other dispensers unless we allow it. But on the back end, IoT Core also has a capability we call the rules engine, where we can create rules. And it's like business logic that can look at the messages that are flowing through on topics, and based on the content of those messages, take different actions. So in this case here, we've got a couple rules, a dispense and a logging rule. They're looking at messages. And if it sees a message of interest, it will then invoke another AWS service outside of IoT Core, in this case, Lambda, to take action. In this case, it may be to update credits on a dispenser, reduce the amount of credits that are available in a DynamoDB table, or just do straight logging to DynamoDB or something like Elasticsearch.
So are these messages in JSON so that then you can already tell the content of the message?
Yes. So even though you can do JSON or binary through IoT Core, by using JSON, it allows the rules engine to be able to see every attribute and do actions such as comparisons, greater than, equal to, and call functions on that to actually transform or even enrich the payload. And that's how we actually do it for which rules are invoked and what actions they take.
Awesome.
All right. So now just transitioning to the bottom portion of this, the other person, we have our participants that interact. So they interact through a web application, and this is a single page application, or SPA, that's served up by a S3 bucket through CloudFront. And we also incorporate Route 53 and Amazon Certificate Manager so that we've got a true HTTPS connection to a friendly endpoint they can type in and get to the actual web page and get rocking from there. When they actually get there, first thing they have to do is we have everybody register. So they put in some credentials, username and password, and there's a validation or verification via SMS. And then they have an account. They have all the credentials, and in the backend, we create all the resources they need for the workshop, such as a Cloud9 instance, a limited role, limited access IAM user, etc.
All right, I love it. It's really cool, and there's just so many components there. Now you're going to talk about API Gateway here?
Yeah, just quickly, is that once you're authenticated, then users can actually call API methods, and we use API Gateway for this. And that way, when our Lambda functions that are backed by that can validate, hey, this user is associated with dispenser 123, so I'm only going to allow them to do actions based on that, and not unlike dispenser 102, which is Anton's.
So then the users interact with the website and not directly with the IoT devices themselves.
Exactly. As I kind of just built out there, like the activate dispenser Lambda in the middle takes in the thing that, hey, I want to do a dispense, and that turns that into an actual MQTT message that's published to the device. So this is sort of a separation of concerns where users from the website or website, yes, they don't actually interface directly with devices, and conversely, devices don't directly interact with the users.
Cool. That makes a lot of sense.
Yeah, and that's pretty much it for the architecture there.
Yeah, I want to now. It's going to be really exciting. I know it's a lot of pressure for a live demo. Always a challenge to do that. But now I really want to see, and probably all the viewers want to see a demo of this, all of this working together, and how it works from the interface to the physical device. Can we do that?
So let me the magic of closing this out. Go to our two browser windows here. And also, and then Anton will show you. So what we have here are two different logins. So on the left-hand side is my login to the dispenser app. And something quickly to call out is that there's a direct link to the documentation. So a participant can go right to documentation, and it's all navigation on the left-hand side, and full rich of all the instructions to take.
That is
great. Back to the important part here. Yeah. So. My dispenser, I'm logged in, for dispenser 100. I stole Anton's credentials. I logged into his account for dispenser 102.
You wouldn't do this in the real workshop, viewers.
Exactly. We want to show that back and forth of like, as a participant, I actually need to give credits to Anton to activate his dispenser. So if you take a look at his dispenser, we got 75 cents, not enough to actually dispense a drink. The button there says need credits. And if we take a look at the dispenser that Anton's holding up, you can see they're all white lights there.
Yep.
So what I'm going to do, I'm going to go back to mine, and I'm going to give him 25 cents. So I'm going to click on Send Credit.
Oh, cool.
It updates on his side, so he now has $1.
Oh, wow.
We notice that the LEDs turn to green. If we take a look on the dispenser, the physical dispenser, it's green. And I can now click on the dispense button and dispense a drink. You ready, Anton?
Yeah.
There we go. Click.
Otherwise, you're going to have a big mess on your hands. There you go.
That's awesome.
Wow, it's very fast. I love it.
Yeah.
And as you noticed, I've ran him out of credit, so his LEDs on his dispenser say red. That there's no way you can do this until we go back to this again.
So
that
it's the
is
social
really
aspect of you've got to be able to communicate with somebody and get them to give you credits. That's really cool. I like that part of it.
So demo complete.
Yeah. That is amazing.
right.
Thank you for that demo. And it went off without a hitch. Congratulations. So this is a really cool idea. How did you guys come up with it?
Well, it started like 3 years ago. We've been deciding how to make an engaging and some quirky workshop for reInvent, because I mean, people going there to learn the things. And we decided to combine electronics with one of the 4 elements. And we decided that the water gonna be the most incompatible. So at the
Fire
end,
is probably
that's
upon.
that's basically what happened. Yeah, I mean the fire, but we were sure that casinos in Las Vegas, they will not allow us to do a lot of stuff with fire, but maybe.
Yeah, next time.
Yeah, live demos are hard enough. I love that you had to add a more difficult element. It's a live, it's a live production with hundreds of people depending on it, and there's the possibility of shorting things out because you spill something. So that's it's a lot to worry about. So you said it uses the siphon effect. Oh, say that again, Aaron.
Yeah. So
I just said everyone loves a little dangerous.
Yeah, of course.
I've been playing with my daughter like some time ago, and I showed her the siphon effect, but obviously on a much less, I would say, complicated setup. It was just a button and this pump motor and the battery. That's pretty much it. And what happened next is that when we decided to go for this workshop, it was actually pretty compelling something to give into the hands of each and every participant. And what was happening is that we just obviously added the microcontroller. We wanted to show the connected system. The first iteration of this workshop was using Mongoose OS, and because we were actually under embargo. And right now, for 2 consecutive years, it uses the FreeRTOS with our libraries. So yeah, it started like that.
That's cool. So now that you know that you're going to have some sort of physical thing, how did you decide what your contraption or setup would physically look like? How did you build the prototype? Because you clearly have a lot of components that have to fit in there pretty tightly.
Yeah, I'm pretty much every time I start with cardboard prototype, because even some of the startup accelerator, they advise people to make very good understanding how the future product gonna look like, created in a cardboard. And what was happening that at the time, there are no shortage in the cardboard right now. I mean, especially right now during COVID, right?
Everything is delivered, so we have stacks of it.
and you can feel right away dimensionally what's going on. So what's happening is that actually I sent him a so this is I found this picture. It was really the first prototype of the thing. So inside of that like middle tube is like a bottle, and it's doing everything that you see here, but obviously in a way more ugly. But the moment you have like a dimensions, you can bring it into the CAD. I've been using FreeCAD, and right now I'm using the Fusion 360. And then you can start building something that can be laser cutted or 3D printed, for example. Actually, this last model, we made it really accessible. If you have a scroll saw, or if you have a 3D printer, or if you have access to laser cutter, it's all will work. I mean, you can make it from plywood, you can make it from plastic, you can make it from acrylic like this.
Got it. So you went from this physical cardboard prototype, you then turned it into a 3D model. You said you used Autodesk Fusion 360. I know a long time ago I looked into some of these tools and they were all super expensive, but you were saying Fusion 360 for personal use is now free. So that's a real easy way to get started. You can take the cardboard, measure it, and plop it in there and get models printed.
Absolutely, and it's not only CAD, it's actually CAD and CAM. So if you need to learn machining, it's a fantastic. And even the price point of the software, even if you want to buy a commercial license and do something, it's very affordable.
And so you said you have your ESP32 on there, but you also have a driver on it. Is that a custom board? I think you said, yeah. Is that custom? Like why custom, and how did you do that?
There are two main reasons. So first of all, as you can see, it has these tabs that actually going into the dispenser, and it's like securely locked there, right? So I mean, it's mechanically also functional, but the main reason we wanted to fit into the budget. So we made this like a short run. Actually, Espressif helped us to even like communicate with manufacturers and make this short run in a very, I would say, the time frame that we needed, right? And finally, we wanted to minimize the number of components with the interconnects, because every time you have like a H-bridge driver board, and then you have microcontroller, then you have LED, it's a failure point. So we wanted to minimize those.
Yeah, that makes sense.
So you put this together. You said the software you used for that was KiCad EDA. So you built it in that. You then get this file, a Gerber file, which you then send to some manufacturer. And software's hard, but I think hardware is harder. And even for experienced designers, you're going to run into problems. I'm curious if you could share some of the, if you had problems, could you share anything that happened with these first things? I imagine you sent the first Gerber file, you got the first boards back, and you were just like, it's amazing, everything works, and you had a huge party, and you were done, right?
Yeah, absolutely. So, the truth is, I mean, one of the stupidest mistakes that I had initially, that some of the pins on ESP32, they're input only, so you can connect sensor there, but you cannot reuse them for the output. And I routed this nice board with this is my hotel room before the workshop, so everything kitting and right. And I routed those pins up to the 32, and the board comes back, and I'm super excited. I'm soldering my first prototype. Boom! It doesn't control the motor. Luckily, we had I routed 2 motors, so at least we were able to use one.
Nice.
Technically, with this board, you can build even like a simple differential drive robot. So I wanted it a little bit like a Lego brick, but it just happened. So that was one of the crazy failure.
Yeah. Wow. That seems like a heartbreaking moment when you realize, this thing is just going to need to be reworked or whatever. I have kind of. Yeah, that's right. Every time you do an update, you got to wait weeks, right? It's not like you commit new code and just it just works out. You got to get something shipped.
And right now it's really, I mean, it's really fast. But I can do the prototype of the board home. I can etch it or route it. But if you want to do it for the workshop, you're talking quantities, and basically every time this PCB comes, it's like, oh my God, will it work?
Yeah, that's I've seen a couple of boards made, and even when you send the right stuff, even mistakes get made at these manufacturers too. So you got to look out for that. So we were saying before, trust but verify, which definitely something always to do, especially with hardware. I was going to say I've got. Oh, I was just going to say, I've got this unhealthy obsession with LEDs and lighting, as people have seen in the past. I'm curious if you could just share what kind of LEDs you're using on there, because they look really cool.
Yeah, so we're using the WS2812B to be precise, and we use the 8 LED ring. So, and what's happening that it also saves us on interconnections. So basically, what's happening is that these LEDs, they're addressable. So you just need the 3 pins. It's like your 3.3 or 5 volts, your ground, and your control wire, right? But that is a kind of blessing and a curse, because right now you have to program it, right? And while there are a bunch of like Arduino libraries, we had to do it from scratch.
Yeah, so I've definitely heard of Fast LED, which is a cool library. I'm sure, Tim, you've used it. So why did you actually have to end up creating your own, I guess, low-level programming or a library and not just use one of those?
So Arduino historically is C++. So all libraries is written in C++. The FreeRTOS that we're using is C, and the Mongoose OS that we're using before was also written in C. So that was the main reason. And while you can do casting and kind of like associate the function in your C code with the object in C++, I mean, it was too much to work, so we just took very similar examples from RMT library and basically reuse that to control these. And I have to say that yeah, this is basically very much a community project, because we had tons of help from Espressive, from our colleagues in ClickAttack, from all our AWS colleagues. Massimiliano was like literally debugging the code for us on a plane from Stockholm to Las Vegas. It's countless people that I'm really thankful to bring this to the point this workshop is right now.
Yeah, so it's important for people to know. Don't do it yourself. Yeah, sorry.
Yeah, it takes a village to raise. Takes a village to raise a workshop baby. I just had to get that
for sure.
Indeed,
sure does.
And one thing I wanted to highlight for people is that you made your own library, and you said that there were maybe some slight quirks with it. Can you just explain to us the challenges you ran into with the LEDs?
Yeah, so the WS2812, while you can't beat bang, then it used a lot of processor cycles, and we wanted to minimize that. So we had two choices: either RMT or I2S subsystems or buses that gives you like hardware very precise timing control over the a signal that you want to send. So we went with RMT, but technically you can reuse the I2S as well.
But you said that there was like a slight flicker that you noticed that you were kind of harping on.
Yeah, indeed. It's basically what was happening is that we noticed it. I don't think anybody in the audience noticed it, but we did. And we're working right now with Espressive to basically like fix it. But because I run out of ideas why it's happening, so I think it's something on a low level drivers. But as I said, I want to try to implement it in I2S, which is historically is audio interface, but people have been doing crazy stuff with it, especially with ESP8266 and ESP32.
Yeah, the thing I wanted to highlight there, though. Oh, sorry, we're all stepping on each other. Sorry, just the thing I wanted to highlight was that when you work on these low-level things like this, I've done this before on a different LED project, but there were a lot of things that I noticed when I implemented my own simple drivers, much simpler than this. It was just a single LED. I would notice a lot of things, and I was always calling it creator's neuroticism, where like you notice it and you're kind of afraid to show it to people, but then nobody else really notices, and it's not really a big deal. And you just have to get over it. But the important thing is never tell them, because if they notice it, they'll never unsee it. That's always very hard to get through.
Indeed.
Sorry, Aaron, I cut you off there.
Oh no, I was just going to say, don't say anything because no one will notice. And then once you point it out, like you said, then everyone's going to see it all the time, and they just can't unsee it.
I found one of the other projects I've done with my daughter, right? It's basically
man. This is amazing.
Yeah,
it's amazing. Is that LEDs or real fire?
Yeah, it's LEDs, and I'm pretty proud of flickering, like to simulate the gas stove. But literally, I was trying to find out that siphon project that I did with her, and I bump into this one at the attic. So,
wow,
it's not
with a little
diffuser
diffuser layer over that. That would look really very convincing. That's pretty awesome. So we've gone through the hardware. We've talked about some of the challenges that you've seen there. I want to get into the software side of things now. And the one thing I noticed immediately was that the documentation is great. First of all, you've got a great architecture diagram you showed us. Then you have that website that shows everything that is all built out. Did you use any specific tools to help you do that? Because I struggle with writing documentation. If there's something to make it easier, I want to know about it.
I usually just leave it to the end.
Exactly.
Yeah, we did it too. We were doing a lot of document writing at reInvent the night before, but we made the decision at the very beginning 3 years ago that all the documentation would be via a website. Which there's a lot of challenges of how do you actually craft this, HTML, these types of things. So for this last one, we actually started to use Hugo, and Hugo essentially is it's a framework that allows you to create static websites from essentially any type of backend file. It could be a text file, Markdown, ASCII doc, even restructured text. And by having all those sort of source files, we could then just run a compilation as we're deploying the infrastructure. It would render the entire site. We upload it to the same S3 bucket where the dispenser app's located. And now everybody's got full access to rich text. So you can see images, videos, even UML diagrams that we generate and render, which gives the participants a much better experience and a way to copy paste code and everything else in some of the other ways. You probably see a lot of this also with other AWS workshops too. They're using the same set of tools and sort of template.
Yeah, it's really convenient. If you're used to writing documentation in Markdown or whatever, like you can add that web element to it really easy. Like I've written tons of Markdown documentation, but it doesn't look pretty like that. So it's cool to know that I can step up my game with something like Hugo.
Supply template.
You mentioned in the that's the hard part. I got to find a template somewhere. All right, well I'll steal yours. So you mentioned you guys are using Cloud9. I see a lot of workshops using Cloud9, and it's super convenient for the web side of things, but there's this last leg of trying to get the firmware that you build in this environment, and you do that because it's a consistent environment for everybody, but the firmware that you build, you need to get it onto the device. And as far as I know, Cloud9 doesn't do that. So how do you bridge that last step?
Yeah, so as mentioned, everybody has their own cloud environment where they're doing the compilation of the firmware. So a lot of CMake files and these types of things, and the output basically are the firmware files, and you need to physically get those onto the device. So the approach that we took is that you download those from Cloud9 to your local laptop, and this could be Windows, Mac, or Linux, and then you use the magic flashing tool to basically copy the files across the USB serial connection over to the ESP32 to actually flash it. So the challenge was, for Mac and Linux, there's a lot of good patterns and sort of commands that are sort of built into the operating system, but there's not for Windows. So we had to find a tool.
Well, you can technically
Yeah.
use it, but installing Python and installing all these libraries for the PySerial, it's much more challenging than let's say installing it. Yeah, so precompiled binaries, this is something what Windows historically using, and Angus Gratton pointed us out that there are like precompiled binary for ESP tools, and it saved our skin multiple times.
Yeah, I can imagine,
Yeah.
because everyone comes with a different kind of computer. Sometimes they come with like the one that was given to them by their company that's a little bit locked down. And sometimes, they come with Windows and maybe they can't install things. Maybe some things can be installed and can't. So I can see that being a little bit of a challenge. And this sounds like it makes it easier across the board.
Yeah, at least for the initial deployment or flashing. But as Anton mentioned up front, is that the next iteration would be to use over-the-air updates, where you've got basic bootloader on there. It can connect to Wi-Fi, and then it can automatically reach out to IoT Core and download the firmware that somebody's compiled and has made available. So we're looking for any magic bullets or silver bullets that can help us bridge that gap from a laptop to a physical device locally.
Yeah, and you said that you've been, I guess, running this workshop and iterating on it over like 3 years or so. So I'm assuming you started off with CloudFormation, and I think you said that you moved it to CDK. So did you have any challenges moving from CloudFormation to using the CDK? Why did you actually do that in the first place?
So for the first 2 years, it was based on CloudFormation, and CloudFormation is awesome because its infrastructure is code. You have a single template, you put in some parameters, click a button, and everything's deployed for you in the background. But what I saw as a novice developer is that if I need to make any slight changes, it could be hard. I mean, the best example is like a VPC. In CloudFormation, a VPC requires 10 to 20 resources before you actually get to the VPC component. And it's like, oh, I want to change CIDR ranges or security groups or route tables. It gets kind of complex. So at the same time last year that we were thinking about how we wanted to iterate in year 3, the CDK or Cloud Development Kit was out. I said, let's go ahead and use this. So I'm a Python programmer, so I did this all in the Python version. There's TypeScript and Java also. And once I saw the thing that I can make a single call, and I'll use the VPC example, a single call to VPC, add in a CIDR range, it does everything in the background for me. And CDK basically just deploys that or creates a CloudFormation template for you. That I wasn't looking back. So the challenge was getting out of the mindset of CloudFormation, managing a JSON and then a YAML document, to being very prescriptive in using like Python or TypeScript to create my code, which then generates my templates, my CloudFormation templates.
So you already had your CloudFormation templates, and you had to kind of move over and retrofit them into CDK or figure out how it works. Did you need to change the way that you thought about building your stacks when you moved to using the CDK? Because I mean, you're going from statically like a written file to more programming approach to creating infrastructure. Yeah.
So one of the things there was that CDK allows you to take inputs like locally, like in a local JSON file, and it uses like local commands to do some of the processing, which ultimately then generates a CloudFormation template. But a lot of times you want to basically be able to give a single template file to somebody that they can load into the CloudFormation console, put in some parameters, and then have the stack be deployed. And originally last year we didn't have parameter support. But we did have that sort of JSON, that local config file. So that's the approach we used for the workshop. But now you can actually generate CDK CloudFormation templates that still have input parameters. Now, they're CloudFormation, so they're immutable. You can't change them once input. But if all of your parameters essentially are sort of static type of things you can put into there, we can now we can give a person a single template. They can deploy the entire backend infrastructure from that one file.
That's awesome. So like Tim brought up when talking to Anton, I'm sure everything went perfectly. Nothing ever went wrong, especially when you're trying to run these workshops with hundreds of people, maybe 100, 200. So what was the most exciting thing that went wrong with the software?
That would be the first year that we did this, and we're being smart. It's like, all right, we know that we need to give like unique credentials and certificates and everything to each person. So let's on the back end generate all of these assets, zip them up into files, put them into an S3 bucket, and then give everybody a pre-signed S3 URL.
Makes sense.
Set the parameters like expire in 36 hours. We're good to go. And then we also used a URL shortener service so that they didn't have to type in that huge long URL, but just a short one. Start on, we go in the workshop. We tell people, all right, go to your URL that we've given you, and hands immediately were being raised saying, I'm getting this thing saying this URL is expired.
Oh no!
I'm thinking to myself, but wait, I set this for 36 hours, so how and that was only like around 12 hours ago. Reading back, because us having Lambda actually generate the pre-signed URLs, it's using role chaining to do that, and it limits what that duration can be. Yeah, you can say this 36 hours, and it'll give you one that's valid, but it was only valid for a short period of time. So pretty big fail right there. We had to give all the files to people individually, so as you can imagine, kind of a nightmare.
Yeah, and you ran into some IAM service limits as well, is that right? Some soft limits that you didn't anticipate?
Yeah, this last year was like, all right, no more third-party URL shorteners, no more pre-signed URLs. We'll basically just, as people log into the website and register for the first time, we'll create all the assets for them. So their things, their certificates, Cloud9. And we'll make this available as just things they can download once they've authenticated to the service. What we didn't realize is that when you test this out with 1 or 2 people, it works fine. But when you suddenly have 100 people all hitting that same step of creating things within a minute of each other, you're flooding the back end, the APIs with all these calls, and you're starting to get timeouts and things like this, and pretty much failed because we didn't take into consideration having 50 to 100 people hitting hammering the services at the same time to create things within our accounts.
Yeah, because if it doesn't work once, why not click it 800 more times?
Right.
Exactly.
Oh yeah, that's another problem. It just it doesn't do retries. People don't do exponential back off. They do the opposite. I don't know what that's called, but it's exponential ramp up where I hit the button 1,000 times. It didn't work.
Yeah. And in my code, it was pretty much create thing 1, create the next thing, third thing, fail. And now you've got these 3 things that have been created, but these other 10 things that have not been created. So, and this is where one of our colleagues basically helped out on this. I basically rewrote the code to be an iterator-based one where it just goes through each thing, like in a nested while loop. And if anything fails at any point, it just sort of backs itself out and deletes everything so that it's a clean state. So combination of back off timers, retry logic, and even sort of spacing things out. Seder Bacon stress tested, so we created unit tests to validate that 100 users could create this within a minute, and then it worked from then on perfectly.
Great.
Nice.
Okay. You guys also mentioned to us previously that you had some physical issues when you were doing the workshop, and one of them that was 2.4 gigahertz support wasn't there. I was wondering if you guys could just talk about that for a second. That seems like a tricky one to deal with.
Yeah, so the ESP32 is an awesome chip. Oh, yeah. So the ESP32 is awesome. It's got 2.4 gigahertz Wi-Fi. It doesn't have 5 gigahertz. We started to realize going to conferences that they weren't offering 5 gigahertz, the conference providers to us like at reInvent, and that you had to have like a special order to have 2.4 gigahertz stood up. And even a couple times we walked into our room 20 minutes before it's going to start, no 2.4 gigahertz. Had to make urgent calls, and they were able to get it set up for us.
Oh, man.
And so we realized that that's a conference where you've got people that are very knowledgeable in helping set up connectivity. But we also run these workshops in like our lofts, AWS lofts, and also even at hotels at other locations that you may have no control over this. And so Anton came with the brilliant idea of, instead of trying to worry about what the hotel or a venue is going to provide, let's just go ahead and get an Aero kit, which is a mesh network, add additional points into a room to basically have good coverage of 2.4 gigahertz, and then use a hardwired Ethernet connection for the actual internet. And Anton's able to do this, and I didn't believe when I said, this is not going to work. He goes, we'll try it. He did it for 250 people. It was rock solid, providing 2.4 gigahertz from a single hardwired Ethernet drop.
That is amazing.
Yeah, and in that particular setup, we just used 4 Aero access points, which was mind blowing.
That's amazing.
Yeah.
And mind, because it's multiplied by 2, because typically people using computer and the ESP, which we've been trying to tell them at least put your computer on a 5 gigahertz, but some did, some didn't.
Sometimes.
Yeah.
Wow. Okay. Well, thank you so much for joining us today. Your project is really cool. It's so interesting to hear about how you guys built it and, actually see it work. I've only heard about it.
Now we can see how hardware is really as hard as people say it is. So we really appreciate you guys taking the time.
Yep. Thank you so much.
Yep. So,
our pleasure.
Speaking of things being challenging, let's move on to our challenge of things. Talk about that.
Challenge of the things.
All right. So we know hundreds of people have already done this, and it's a community project. Lots of people have contributed, but we always want to know, is there anything that when you watch this, you thought like, oh, I wish the drink dispenser did this, or I wish it worked this way. Maybe hook it up to your Twitch stream. We talked about the social aspect of getting credits. Maybe people could post messages in your stream and you could get coins from that, maybe automatically distribute drinks when you're doing your own Twitch show. So
maybe
if you've got any
sensor.
cool ideas.
I think that would be really cool. Maybe do that. So tweet us your solution at #alltheexperiments. Yeah, there you go.
Cool. And I think that rounds out another episode. So check the chat stream for the resources that we talked about during the show.
And be sure to join us on our next episode in 2 weeks, September 20th. Watch for announcements. We're going to be looking at project experiments from the edge to the cloud. So send us all your cool ideas. We really can't wait to hear from you. We want to hear all your crazy ideas. So let us know.
Thanks again, everybody.
Thank you.
Yeah, and we'll see you next time on IoT All the Things.
Special Projects Edition.